All right. Good afternoon, everyone. Second to last session before the big event. We're going to be talking about, we're both from the University of Chicago. I'm Eric Giles. This is Abe Shager. We're going to be talking about achieving high availability through a centralized approach to IT monitoring. So we've got some cursory slides to get through here. Yes, the infotainment slide. And then here's our abstract, which I'm assuming is what brought you here. And then a little bit of what we're going to go through. Our background, our approach, and then we'll talk about our three phases. A little bit comparing UIM and eHealth, and then questions. So first of all, we're from the University of Chicago, and I always like to talk a little bit about the University of Chicago. It was founded in 1890 by Al Rockefeller. We have Big Chapel for him. We have about 6,000 undergrads, about 10,000 graduate students, which is interesting because we have more graduate students than undergrads. And then we're a research institution, so we have 8,000 staff and researchers. We're most notable for our Nobel Prize winners. We have 89, but most people don't know that we actually won the first Heisman winner in 1935, a guy by the name of Jerry Bearwanger, if I could pronounce that correctly. But most people don't know, actually it wasn't called the Heisman Trophy for the first year. It was called the DAC Trophy for the Downtown Athletic Club. So if you don't remember anything else from our presentation, you can have that little tidbit of knowledge that the first Heisman wasn't actually called Heisman. It was only called Heisman the second year, and the first winner was from the University of Chicago. That said, other things about us, we have extensions, we have our main campus, but we have extensions in New Delhi, Paris, London, and Hong Kong. So we extend around the globe. A little bit about us. So I'm the command center manager. I'm also have another title as best practice consultant for service management. I've been running command centers and their tools since 2004. I've been in technology since 1996. Have a couple of advanced degrees, and I've worked at some other companies. Abe, I'll let you talk about you.
I am the lead reporting engineer at the University of Chicago. I've been in monitoring since about 2010. I've been in IT for 17 years. I've worked with State Farm, Motorola, the federal government with the Department of Veterans Affairs. I've also worked in education as well with DeVry University. And I've been at the University of Chicago for about 2 years now, close to 2 years.
All right. So, our environment, just so people can understand a little bit how you would compare to us. We've been running UIM and Spectrum and eHealth since about 2011. We currently monitor over 5,000 devices across the globe, about 35,000 individual alarms and thresholds. We are currently integrating 6 other, so we use the integration suites. We're integrating 6 other monitoring tools, things like SCCM, vCenter, ISX. We are watched, our systems are watched 24/7 by a command center team that I also manage, and we directly interface with 13 other infrastructure teams. So that's a little bit about our environment. And then a little bit about our architecture. Abe, you want to describe our architecture a little bit?
We kind of have a smaller architecture compared to most of the other people that I've seen presenting here. We have high availability both on the Spectrum side and on the NIMSOF side. Spectrum side, we only have one landscape. We can get away with that by having 5,000 models in there because a large majority of them are wireless APs, which are ping only. On the NIMSOF side, we have a distributed architecture where we have primary and standby for UIM. We have a separate database server, and we also have a separate front-end server, our UMP. There we also have another separate server, which is where we input our SNMP collector. And this is where we do the majority of our monitoring. We have things split up as well in 2 data centers, which are housed locally on the University of Chicago. We don't have any offsite data centers, and we use that so that our backups are in a physical separate location than our primary for failover purposes.
All right. So what we're going to do and go through this presentation is I'm going to handle kind of the business side, and then Abe's going to handle the technical. So if you've come here and you run on the business side, I'll be presenting that kind of detail, and then Abe will be presenting some of the technical stuff. So to get started, when I first came to University of Chicago, we really didn't have the system set up. We had bought the systems and we had installed it, but we really hadn't started pushing out monitoring. It wasn't operational. And I had worked in 3 or 4 other locations where monitoring had been purchased and set up, but the easiest way to describe it is in the operational environments, it was just page after page of red screens. And people would tell me, oh, well, you got to know the system to know the criticals from the non-criticals. And we didn't have time to get all the configuration, to get it all tuned and cleaned up. And having a kind of greenfield environment, I said, I'm not doing that. So I hired Abe about 8 months after we started, and my direction from the beginning is that the operational team will always have clean screens and be able to respond to all the alarms that we operationalize. Whether that's writing a ticket, whether that's escalating, whether that's starting a bridge, none of this, you got to figure out the alarms. And so in order to do that, I had to take a different approach, and that's what a little bit what I'm going to talk about here. When I got there, my predecessor had said, okay, well, we're only going to do the servers first, just the servers, because we can't get the rest of the teams on board. And there's a bunch of complications. They had a long list of technical challenges. And I, after having my experience, I killed that. And I said we were going to go with a broad, then deep strategy, which is what we're going to talk about here, which means that we were going to bring every single device, every production, every device, all of the VoIP infrastructure, all the storage, every piece of hardware, every single piece of hardware that we had anywhere on the globe was going to be in the system. And we said, just to bring it all online, we were going to do just ping only. So there was the minimum, I kind of using the minimum viable design approach. We said, what's the minimum viable thing we can do to get every device in here? And that should have been, everyone said, well, that's too easy. What's the value of doing that? And I'm going to get to the value of that in a second. But it actually ended up defining our whole strategy, because we ended up, phase 1 was just ping. It took us about 6 months to do, but we were able to then come up with a phase 2, and we're about to start our phase 3. The trade-off with doing this broad then deep is, you get the wins. I mean, one thing that's been reinforced for me here is just how important the operational element is. How to make sure that your operators, the guys that are responding to the alarms, are as involved and a part of the design process as the monitoring team that's building it. And when we started with just ping only, we really had the opportunity for people to build relationships with all of the 13 different infrastructure teams at a very basic level, only responding to basic connectivity. And that paid off when we went into phase 2 and we were looking for more complicated technology to introduce. It also it brought everybody to the table, and so this is really what you get with a broad then deep strategy. So this kind of comes down to why we chose this. I mean, we could see everything in our environment, and what this eliminated was that kind of finger pointing that you get a lot of times, where application people will tell you it's a network problem. The database people will blame the application people. The server people will blame somebody else. When everyone could see everyone else's stuff, we eliminated that finger pointing, and everyone just became a lot more accountable. I talked to a couple other universities, and they had the challenge where they had stood up one side, but they were having a heck of a time. They had stood up the network people, but what the network people wanted had nothing in common with what the server people had wanted. And now trying to figure out how to rework it for the server people was unmanageable. When we started with just ping, and then we brought in just integrated and SNMP, everyone had skin in the game. And that meant that our culture and our technology could evolve at the same time. And that really became a key element of our success. So we went with this phased approach, right? We're going to go broad then deep. We're going to have a clear set of phases. Our first phase was ping only. Like I said, minimum viable approach. There was really nothing less than we could do than just ping the device. But what was interesting was, we had some pretty amazing outcomes from just doing ping only. The second phase was our hardware base, where we either integrated the tools they had, like SCCM, or we did polling. We didn't do any probes. We used these 2 approaches, but all of the hardware had to be brought in. Our third approach is then to realign this, because these are all bucketed, and it was going to show you in containers by hardware, to then re-bucket it by service. knowing that all of the hardware for that particular service is actually in the system. So, each phase with this phased approach kind of has the following elements. The phases are going to have unique teams. Primarily at the beginning for phase one, it was all about the networks, because we had a lot of firewall rules and a lot to deal with on the networks just to be able to connect by ICMP to all the devices. But by the time we got to the next phase, it was all about hardware. It was all of the hardware teams. The application people didn't really have skin in the game yet. But now that we're heading into phase three, it's very minimal with the hardware and a lot of application teams. The second thing is each phase had very specific outcomes. This is what we had to sell to management. So they wanted to know what were they going to see, not 5 years from now, but in months from now. And so each of these phases had hard, and we had metrics to show them how we were doing. The other thing was we created templated deliverables. We made it very easy for all of the teams to deliver what they needed. And then we ran standing meetings, both technical and leadership, to keep buy-in. And this was really important, and this is what I sold from the beginning. I use a metaphor of building a house, and that is we had to build the foundation before we went to the next phase. And I would constantly tell people, I realize that it's raining and we need a roof, but if we haven't poured the foundation, we're just going to have to rebuild the roof later. And people may be in a hurry, but if you haven't got walls, putting in the electric doesn't make any sense. And this seemed to resonate with people. So our phases were very much built on top of each other. My tip was to tie the outage reduction to tie it to outage reduction and service management metrics. This was really key, and it helped us continue to sell the story.
If I can touch on something that you mentioned about the goals and outcomes, something from the technical side, the technical meetings that we hold on a week-to-week basis, a lot of the engineers felt like, why are we here? Why are we doing this? And having that goals and outcome as a focus of our project. Every week we went through that slide, every week we reviewed the goals and outcomes, helped a lot because it let the engineering teams know that this isn't arbitrary, we're not here to waste anybody's time, we are here for a specific purpose. This is the goal, we want to reduce Sev 1 incidents, the outcome is we want to capture the majority of them in UIM or in Spectrum. So goals and outcomes, I think, were very key in both getting phase one, phase two, and what's soon to be phase three up and running.
So what we ended up with, this is a meeting I had about 8 months ago when the senior leadership called us all together and wanted to know how we were doing. And I had this slide to show them. And this was really, if there had been skepticism up until that point, this eliminated it, which is we had been averaging about a major Sev 1 outage, everyone on the call, one a week. And we'd been doing this for years. And when we first introduced monitoring, first thing that happened is, we had a whole bunch more outages really fast because all the things that had been slipping by all of a sudden were caught. But once we were over that, our outages went down drastically every quarter, significantly, almost cut in half. We're down right now to less than one outage a month. And that means, and that affects everybody, because when we had an outage, all the senior leaders were involved a good majority of the time. I mean, when we were losing an entire data center, when we were losing all of wireless for the campus, everyone was involved. If you can eliminate those, that's the kind of value. And we did that primarily, at least at first, with ping only. We were able to see these kind of results. And there were a lot of people who questioned our approach of this kind of everything broad than deep. And all of that went away basically as soon as this data came in. So one of the things I can't stress enough is keep lots of data, because this helps you sell the story. If this is what sold the story to management, this is what sold the story to the technical teams. When the technical teams saw what their uptime really looked like and that they could distribute those uptime reports to their customers, that's what sold them on the approach. We're currently, although when we wrote this chart, because we put this in about a month ago, our last quarter, we're actually getting really close to an average of 4 nines of uptime on our hardware. And a lot of people will talk about how within the services economy, does uptime matter anymore? Well, it still matters to your infrastructure guys. They are still worried about that, and that's how you can get the buy-in at the infrastructure level. So, phase one, connectivity. So, going back to our goals and objectives, here's what we did. They may be different for different people, but our simple goal was just to get every device into Spectrum via simple ping. I'm a big fan of simple is easy to understand. Everybody knew what we were doing. And we had these 4 standard objectives. We were going to capture 95% of the outages in monitoring. We were going to monitor all the hardware. We were going to operationalize monitoring, meaning all of the alarms would be watched by our NOC staff. And then we were going to report on hardware uptime and alarm counts. And that was it. And when we did that, we exceeded all of our goals just by keeping it that simple and staying committed to that level of monitoring. We exceeded our outage capture targets. We captured 98% with ping only. And now that may seem strange because I'm sure there were degradations in service, and what this has allowed us to do is kind of raise the bar. You know, this was our definition of an outage. Now the teams are going back and looking and saying maybe we need to redefine what an outage is, but that's success as far as we're concerned. Getting all the hardware integrated was a lot harder than you would think. It took us several months to deal with the firewall rules, to deal with getting all the devices loaded, to getting all of the equipment in. It wasn't a simple task. Letting the operational team see the alarms was a huge cultural shift. It took a lot of time, a lot of trust, and a lot of consistency on the part of our NOC in order to get them to trust the other team. And we spent a lot of time trying to get the operational side right and consistent, which was what was key. Because we're calling people at 3 in the morning, and they don't want to be called unless it's real.
I also think that level of visibility was something that kind of had all the different engineering teams step up their own game.
Right, yeah.
Now that they know that there are events related to their hardware that was going to get forwarded to the command center, they kind of stepped their game up a little bit, and that actually helped our overall goal as well.
Right. So, and it helped us avoid politics by focusing on the data, right? It was either up or it wasn't. They could ping it, they could see that it wasn't up. It wasn't some abstract level. So this is what we did. With that said, there were some challenges, and I want to let Abe kind of talk about a little bit of the technical challenges.
Coming into higher education, there was one key thing which all of these challenges that we had are going to revolve around one issue. The campus has a lot of bandwidth coming into it. It's an attractive target to hackers. It's a jump station for DDoS attacks. There are a lot of students who like to mess around with the network, so because of that, security is a top priority. They have hardware firewalls, they have software firewalls, they have firewalls on top of firewalls, they have ACLs, and it can be a headache from trying to institute something because you spend a lot of time troubleshooting certain issues that you think are related to the application itself, but in turn it's usually some type of blocked port or an ACL or something that's not allowed. And starting off with the first point, ICMP was blocked in most locations. They don't allow anything except for port 22 to get to the box, and then anything else that a specific team has opened up for communication purposes. Software firewall issues was something extended to that, but that's local. Like with the majority of our UIM and Spectrum infrastructure is run on Linux, so IP tables were in place. Those had to get ports opened up for database ports between our UIM server and our database server, or our UIM server and our Tomcat server, which is UMP. And network ACLs went along with that. We have a Cisco architecture, we have distribution and aggregation layer, and all those ACLs had to be updated as well with the ports that need to be opened up. Something else, they tend to use IP addresses, and there were old DNS entries in there. And so whenever we would import something that they would give us an old host name or an old IP address, it would create an issue with when they would call out somebody, okay, this server's down. No, that server name is wrong. So we did have to also clean up and go through all our DNS entries.
Right. Thanks, Abe. I mean, and a lot, I can't stress how important this step is to work out all the operational kinks. Just the idea of working with our service management team and changes so that when devices were added or taken away, these kinds of things all are really important, and you don't need all of the complexity of a complex monitoring solution in order to address those. You want to keep it as simple, and that's what we're able to do with the phase 1 ping. Going to our next phase, which we're just finishing, is where I just called it simply the SNMP phase. And this was to get as many devices on SNMP as we had licenses and integrate the rest so that we could be proactive at the hardware level. This particular strategy, my goal was to reduce outages by 50%. You could see further down the slide, I ended up reducing our outages by 300%. And a lot of the credit for this actually goes out to the technical teams, because there's something that happens with the technical guys when they start to see how their hardware is really performing, but even more so when they're seeing how their hardware is performing in an environment where all the other technical teams can also see how their hardware is performing. And that kind of synergy all brought together really benefits the organization as a whole. Our second goal was to reduce the severity 1 through 3 incidents on all of this hardware by 50%, which we accomplished. And then it was to operationalize the non-outage events. And this is where we started to get proactive. So now we're writing tickets and opening calls before there's an outage, just to let people know, hey, your hardware is degraded. And one of the things I joke with the team, like, we're going to get to a place where we basically don't have outages, at least outside the realm of through change. And I make the argument that's possible. If we set this right and we continue to refine our targets, I think we can get there. But again, this is all in that proactive space. And then finally, able to produce real-time dashboards so that now we could bring management into the picture and they could start to see a lot of what we were doing. We exceeded, like I said, we exceeded our outages goals. We got to a 300% reduction. I actually ended up posting one of those safety things, see number of days since last accident, only I would say number of days since last outage, when we would update it every day. People thought I was crazy, like we were jinxing ourselves, but that I wanted to really market and take advantage of how long we were going. And I think we got almost to 97 days last year without a Sev1 outage. So it does happen. I will say that exactly 0 teams wanted to commit to this phase when we introduced it. It seemed like a bunch of work. The common things we heard were, we already have monitoring, we don't need you guys, we know how our stuff performs, we're too busy, we have too many other projects, we can't bring this in. So that's where I talked about all the templates and everything. We had deliverables, we had very specific things for them to do, as well as a high level of management visibility. But I don't know anyone who's ever implemented this that had the teams come in and say, yeah, we can't wait to have some third-party group monitor our hardware. There was a huge emphasis on cleaning up technical debt. I would argue if you're an organization and you have a ton of technical debt, introducing a monitoring solution is actually a great way to deal with the technical debt. Rather than going in and trying to find it, your monitoring can be a way to find all of that stuff, because you will find a lot of it. And I joke that with our teams, we had a 300% reduction, but that wasn't because of us. I mean, we introduced monitoring, but they're the ones that cleaned up all that technical debt. And that was a big a win for the organization, but we were just there to report on what they were doing. And one of the things that is interesting about this phase is that we had a lot of people who didn't understand the difference between events and performance data. So that was one of our challenges. The notion of saying that an event is I exceeded, CPU, my CPU threshold for a major event for 10 minutes, as opposed to a real-time performance data just telling me what my CPU is. Those two kinds of reporting became important, and I had to socialize that with management so they would learn the difference on what that meant. That measuring performance isn't the same as measuring an alarm or an event. And I will end with saying the best work that was done by Abe and the technical team, and just getting smart guys locked in a room and working out how to solve these problems. So with that, Abe has some notes on, technical notes on how best to do this phase.
So with phase 2, a lot of the issues that we had with the first part are the same issues that we had with the second part. Instead of getting ports open for ICMP, we had to get ports open for SNMP. Device certification was also a little bit difficult with ping. You don't need any type of communication other than, can I see you? Yes, I can. You move forward. With SNMP, there's a little bit difference. You have to have a community string. You have to make sure that the device is known to UIM and to Spectrum as what it is. You don't want to monitor an Infoblox DNS server as a Linux server. So getting the devices certified, getting them properly into UIM and into Spectrum as what they are was key. We did have a lot of lack of SNMP support with some of our older technology. We had some mainframe printers, we had some mainframe devices, we had some stuff that was out of the box, so there was no SNMP support. So in some cases we would reach out to the engineering teams to see if they can talk to their vendors and see if there was something we can do about that. So that was one of our other technical issues. NATed IP addresses, SNMP doesn't always necessarily forward to something that is hidden behind a DMZ or something that isn't supposed to be routable. We do have a lot of research that is non-routable IP addresses, so some of those IPs were NATed. We had issues with that. On the Linux and Windows side, we could not install agents. Having system edge agents or maybe putting on some UIM probes, they did not allow that, so we had to use exclusively SNMP in some of those situations. And because we couldn't put some of those probes and agents on the servers, you had to really do some creative work to try and get the same level of monitoring that we would if we were to be able to put a system edge agent on there, or if we were able to put a specific probe from UIM. Lots of third-party monitoring systems. So our Linux team has their own, our Windows team had their own, our VoIP team, our virtualization team all had their own different types of monitoring systems that they had set up and that they had monitored and they had executed over the course of years, and they still wanted those events coming in. So we had a lot of third-party integrations to set up, and that in of itself created a lot of issues because all the fields don't always necessarily match up. A field in SCCM might not necessarily mean the same field in Spectrum. So those mapping issues that we had probably caused more time from integrating those third-party integrations rather than if we were to go ahead and monitor it natively in UIM or in Spectrum. Next slide. So from ICMP to SNMP, there was a little bit of an uptick in network traffic specifically. We worked with our networking team to see where SNMP was highest, because not only were we using it just for monitoring, but we were also using it for reporting. So our reporting servers, which are doing polls every 10, 15, 20 minutes, they were causing an increase in traffic, which was putting a little bit of load on some of the older hardware, which was already at 75, 80% CPU utilization. So we did used to have to either ratchet down some of the polling levels, or we had to ratchet down what it was that we were monitoring in certain locations to work with the issues that we were having with networking. Our architectural diagram, we were dealing with a situation when I was doing upgrades and there was certain one-click servers that weren't present, which caused a hiccup in our reporting database. That was also an issue. LDAP problems with UIM, we're a pretty big Linux setup at the university, and UIM supports AD and eDirectory. And with that, we had to kind of migrate our LDAP authentication to AD as opposed to what we had going with Spectrum. Uniformity across user accounts. We had a lot of splintered different security issues for certain users. So this user group would be able to see alarms, this user group would only be able to see events, this user group would have access to view this kind of hardware. So we kind of wanted to flatten it out, make sure that all teams can see kind of the same amount of information, get everything a little bit more organized, and we kind of set it along logically to the different groups. So servers would be able to see not only Linux servers, but the things that they touched. So virtualization would interact with storage, they would interact with networking. So we wanted to make sure that everybody had the proper privileges to see everything else, as opposed to just being siloed as it was beforehand. And one of the last technical issues that we dealt with is we do have a lot of users that don't have administrative rights to their computers. So on the Spectrum side, there is a jar file that has to be put in place, and that caused issues in getting the actual application up because they would have to open up a desktop support. There are some upgrades coming on the Spectrum side with 10.1, which will allow a web interface, so there won't be any need for Java to be installed, which is going to help out a lot. And those 11 were probably the primary things that we dealt with going into phase 2.
All right. So that brings us to phase 3, and this is a service view. So the way that I describe this is once we have all the hardware and we're monitoring all the hardware and we know the uptime of the hardware, I called it the slicing and dicing problem. So I had 13 containers of hardware, and yet management really didn't care that the Unix systems were up. What they wanted to know was whether email was up. And that meant that we had to take all of the hardware and now re-bucket it according to services. And because we had all of the hardware, we had every piece of hardware from storage to network to UPS, all in there, we could tell you every single device. So what we're doing now going into phase 3 is we're meeting with every single service owner, and they're bringing their application diagrams, right, to us so that we can put all of their hardware into its own containers, then reviewing the thresholds that the hardware team created, adding additional alarms where appropriate so that now we can create a service-centric view of the same hardware. And that's our goal. And I mean, that's what we're trying to do. What we're hoping to get out of that is at least now 3 nines of uptime for all the services. You know, and that's 44 minutes a month, 44 minutes downtime a month, which is a pretty audacious goal, we thought, until we realized that we could do it with hardware, so why can't we do it with services? So the other side of it was, because we didn't have a services view, our command center was only calling our hardware folks when we had downtime. And our goal for phase 3 is now to be able to call service owners and have them and hardware people at the same time so they could all be on the outage bridges together at the same time, so we would know what the impact for a particular set of hardware would be. And then finally, the creation of vanity dashboards that will allow you to see by service so that we could publish. So if somebody said, hey, I'm having problems with email, they'd be able to go to a dashboard and see the performance of the email system itself. I'd love to be able to tell you the outcomes, but we're not there yet. The interesting thing is that where we had to corral the hardware team, the application team has been breaking down our door to get this. They really want this. It's a little mind-blowing for us after having gone through a year of fighting with the infrastructure teams to have to have the application teams coming to us and saying, when can we do this? How fast can we have this up? The only challenge for us is, I think we had 13 infrastructure teams. We have, I think we have almost 40 application services teams. So there's a lot more of them to work with.
And that was after dwindling it down.
And that was after dwindling it down. That's right. We realized we couldn't do all the possible services. So, but what's interesting also on that note is there were a couple times where we had to kind of cut deals with infrastructure teams, and we told them at the time, you realize that when the application folks come in, they're not really going to like the fact that you chose not to put this kind of alarm on, or that you chose to set the threshold at this level. But we'll go ahead and let the application teams come in. And now we're having to play some of that catch up. And the infrastructure people, instead of us telling them, it's the application people coming and saying, I want an alarm on that. You know, I want the threshold set here. The other thing which is interesting is we don't really have what would be a working CMDB, or at least we don't think we do, but everyone now keeps referring to all of our artifacts for building phase 2 and phase 3. They keep calling it the new CMDB because we have it all in there. And so we've become the foundational element for the CMDB that they're building. So if you're actually looking to build a CMDB, or you're looking to rebuild one because the one you have don't working, starting with this approach gives you all the foundational elements. All the hardware is in there, all the architecture is in there, all the connectivity between all the devices for the services is in there. You just have to go and fill out the rest. And you know, it's in here. Some of the web-based services people team started coming to me about 6 months ago, and they were just banging the drum on synthetic transaction monitoring. You know, we need this, we've got to have it, it's expensive, we were looking at it. And what's been interesting here is I've heard the same story from other people that are running these tools. It's great, but it doesn't really tell you what's going on with the hardware. It just tells you that the user, the customer, is having an issue. And so what we've had to do is kind of sell people that it really requires both of these systems to be working together. But you're going to hear about synthetic transaction monitoring when you're doing this, and it complements what you're doing with this kind of approach, but it in no way could replace it. And then, like I said, because we totally changed teams, now we've got all these application teams. It feels like we're kind of starting over in an interesting way. Some things better and some things, worse. So one of the things I was going to talk about was our transition. We had originally were using eHealth, and that was all we had license to. And we actually had to convert over to UIM. And so one of the things that, when they asked me to do this presentation, they said, people are going to be interested about this conversion. And so I'm going to talk a little bit about the business advantages, and Abe's going to talk a little bit about the technical challenges. But we actually were an eHealth shop. We really actually tried to make eHealth work for about a year, and then we gave up and went over to UIM. So for us, one of the reasons we made the conversion was it was huge improvement in capability and scalability than what we were dealing with eHealth. We just ran into lots and lots of scalability issues. It significantly improved the look and feel. The dashboards that we got they just weren't pretty to show to management. I don't know how else to explain it. They just felt very dated. The quality and the currentness of the technical support, we felt like when we called and had an issue on UIM, it was much easier to get support. The people we're talking to, we felt like we're able to resolve issues a lot more quickly. And then clearly, based on everything we're seeing here, we knew we were making a choice to kind of future-proof ourselves. But there were some technical challenges, and Abe's going to talk about those.
Once again, we had to mess with more firewall rules. I noticed that that's a recurring theme at the university. Also with EEM, which is Embedded Entitlements Management, it's a single sign-on server that CA employs. It was a way for somebody to authenticate once into one of CA's products. And if you were to port over into another one of CA's products, you wouldn't have to re-authenticate. EEM is available for Spectrum and eHealth, but they currently don't have that integrated with Spectrum to UIM. So while it's a minor glitch, people didn't like the fact that they had to authenticate twice, once into UIM and then once again into Spectrum. They are, with version 10.1, releasing a bidirectional communication between the two, so that might fix that, but as of the current release right now, you will have to authenticate twice. So that was a little bit of a nuisance for some of the end users. Whatever you had set up in eHealth, so you couldn't just do an export on a certain report or an export on a certain dashboard from eHealth into UIM. So any dashboards or reports that were built in eHealth, you are going to have to reproduce those efforts into UIM. UIM is an easy setup. It monitors a lot more than what eHealth can. You are still going to get your performance data, so if you want network utilization, you're going to get it. If you want to get interface utilization, you're going to get it. But UIM also does other things. They have a bunch of probes out there. We were able to get storage information. We can get virtual information, so the effort is worth it. Moving from eHealth to UIM really was a no-brainer. It was something that I was looking forward to. There is a learning curve. The architectures are different. eHealth, we primarily had on one server. Everything was located. The web server, the database, and the application itself all sit on the same box, whereas with UIM, we had 3 or 4 different servers, and the upkeep is a little bit more, but as I said, there's a lot more features with UIM than it was with eHealth.
So one of the things that we're dealing with, and it's always interesting in higher education because we feel like we're a little behind a lot of other things, but synthetic transaction monitoring kind of came to the radar for us about a year ago. And it was designed as this thing we were getting from our web services thing as the thing that we have to do from a customer experience point of view. And they were selling it, it was being marketed as a replacement cost-wise for our current monitoring solution. Now, I'm thinking among this audience, you recognize that's not realistic, but for the web services guys, you know, and the kind of .com, it was going to, you know, boil the ocean and save the world and cure cancer. But that said, I think it does have a place and can be a key element of your strategy. It's not going to be the whole thing. So it will find more things because it's focused on the end user experience. It's going to see things that you're not going to see from a ground up approach. Things that are, you know, it's bugs in your code, it's that kind of stuff. It's going to catch that the infrastructure may be all running. It will give you that customer experience in a way that the traditional monitoring, bottoms-up infrastructure monitoring kind of struggles. Only if you've got to be pretty sophisticated in your alarming to get to the level that even the most simple of synthetic transaction monitoring can do. And it's really hard to argue with how easy it is to set up. I mean, with all the work that we had, it took months. The guys with synthetic transaction would come and be like, well, we'll be done tomorrow. You know, just come in, get your web pages, log in, go a couple layers deep. It's hard to argue. It is much easier to set up. But I think most people realize it's not really a complete solution. It won't tell you what's actually wrong. This is my favorite, right? It's like, hey, there's something wrong. We don't know what, but you know, somebody can't log in. And then if you're the guy, the operations guy, and you got to get people on a call, you know, who do you call? Everybody, right? Because you don't know. Is it a database? Is it a network problem? Is it an application problem? It does nothing for you in terms of the operations team knowing exactly who to engage and how to start working it. My argument is to actually compare what you get with traditional infrastructure monitoring and synthetic transaction. It's not actually cheaper. It's cheaper on one hand to kind of maybe get started, but if you want to actually have the visibility that you would have, you're going to spend a ton of money on the data, on the upkeep, on the changes. I would argue it's not cheaper. And in the end, I don't think it's a complete solution. I know I was talking to one gentleman today, and they asked him what his goals over the next 18 months were, and he said was to rip out synthetic transaction monitoring. They had bought it, they had used it, they had it in for a year and a half, and now they were done with it. I don't know if I agree with that, but it gives you a sense of where the life cycle is with synthetic transaction. We do plan to use it down the line, unless, you know, my VP of Web Services gets his way and we get it tomorrow, in which case we'll set it up because it'll take about a day and a half. But you know, we do plan. It will improve our enterprise solution by identifying issues that we haven't configured for yet. I mean, to me, the best part of it is that I can take every alarm I get in the synthetic transaction side, go find the cause on the infrastructure monitoring side, and then alarm for that. And then I can prevent that from happening. And I may not have known about it if I didn't have the synthetic transaction monitoring going there. It does give us a solution for cloud-based tools. So, you know, we run Workday, we run ServiceNow. It gives me at least a way to say that I'm monitoring these tools. And, you know, I can put up alarms for connectivity and latency. So I think it does have a purpose, but I don't think it in any way replaces synthetic our traditional monitoring. I think that's it for our content. So these were just some of our achievements. We did improve our scalability. We have improved service. We're almost at 4 nines, and like I said, we were able to reduce our outages by 300%, which has been probably our most tangible benefit to the organization with this approach. So with that said, I think it's time we have 1 minute and 30 seconds for Q&A. And then we could take people's questions at the side here if people have any questions. I'm sorry?
There's a microphone. Yeah.
What are the different product sets you guys use for monitoring?
For monitoring. He's asking, the question was what different products are we using for monitoring? Primarily we use UIM and Spectrum. We also have NetFlow, which we're currently integrating. There's a real good integration with UIM and NetFlow, which will help with a lot of the utilization on the network side.
So how are you guys then putting the service context across using those tools? Are you using the service from Spectrum, or are you actually looking at a different product?
Service context?
Yeah. So you said you guys are creating a service context, right?
Services are being set up in Spectrum. We're looking forward to the bidirectional integration that they're going to release in 10.1. This is going to give the strength of Spectrum, which is the RCA, and it's going to import that into NIMSoft. So any RCA that happens on the Spectrum side, it's going to communicate properly with NIMSoft and associate the two. I'm sorry, UIM.
Any other questions?
Are you guys using Spectrum as a mount or UIM as a mount?
Oh. So, okay, so we're told, but we can answer any questions over here if anyone, they're just very rigid that we need to get off the stage now. So, thank you everyone and enjoy the rest of the conference.